In this video, we're going to start talking about probability. The first type of probability we're going to be talking about is empirical approximation or experimental probability. This is the number of times an event has actually happened divided by the total number of attempts or the total number of trials. As the number of attempts increases, the cumulative fraction of successes will get closer to the true probability. So we'll look at some examples of this. First, let's suppose a coin is flipped 20 times and it lands on heads 11 times. What is the experimental probability of this coin landing on heads? So we flip the coin 20 times, so we have 20 attempts, and the event or success we're looking for is landing on heads. And this happened 11 times. So our experimental probability of landing on heads would be 11 out of 20, or 55%. Now we know that the real probability of flipping a coin and landing on heads should be 50-50, but this is experimental probability, and this has to do with what has actually happened in our experiment. So in our experiment, we flipped this coin 20 times, we landed on heads 11 times, so our experimental probability of landing on heads would be 11 out of 20. I suggest trying to figure out the next example on your own, then hit play to see me go through the answer. Suppose a 6-sided die is rolled 30 times and it lands on 3 6 times. What is the experimental probability of this die landing on 3? So we've rolled the die 30 times, meaning we've made 30 attempts, and we've landed on 3 6 times, meaning the number 3 has only shown up 6 out of 30 times. So our experimental probability would be 6 out of 30, or 20%. Now to explain what we mean when we say, as the number of attempts increases, the cumulative fraction of successes is going to get closer to the true probability. There's something called the law of large numbers. This basically says if we repeat an experiment many, many times, the cumulative fraction of successes, or the times that the event actually happens, will tend to draw closer and closer to the true probability. Like in this last example over here, we flip the coin 20 times. 55% is somewhat close to 50%, but flipping the coin 20 times isn't a lot of times. What the law of large number is telling us is that if we flip this coin 100 times, 1,000 times, 1,000,000 times, that if we added up all of the amount of times we got heads, it would probably come out to be a lot closer to 50% the more and more times you carry out the experiment. So we'll look at an example of this. Let's say that we've had some coin, we have flipped it 70 times, or we had 7 people each flip the coin 10 times, something like that, and we all recorded the number of tails we got. We can find the experimental probability for each group of 10 flips. So we would have 4 out of 10, 7 out of 10, and so on. If we look at these experimental probabilities, they kind of seem to be a little bit all over the place. Sometimes they're below 50%, sometimes they're above 50%, sometimes they're at 50%, but they're not consistently near 50%. Next, we'll look at the cumulative number of coin tosses and the cumulative number of tails. So what we mean by cumulative is we're adding everything from the past together. So we're taking these 10 flips that we did initially, and now we're adding the next 10 flips to it. So we've done 20 flips at this point, and then at this point we'll have done 30 flips. At this point we'll have done 40 flips, and so on. For our cumulative number of tails, we're just going to take the amount of tails we got in the previous trial and add it to the next trial. Now that we have all of our cumulative number of tails, we can find the cumulative fraction of successes. And this is going to be cumulative number of tails over the cumulative number of coin tosses. So at first our fraction is just 4 out of 10, or 40%. Then when we add another 10 flips onto that, we have 11 out of 20, or 55%. When we flip the coin 10 more times, now we're at 14 out of 30. Or 46.67%. We flip the coin 10 more times, we end up at 20 out of 40, or 50%. We flip the coin 10 more times again, we end up at 24 out of 50, or 48%. Then we get to 32 out of 60, 53.33%. Then we get to 37 out of 70, or 52.86%. And now if we look at our cumulative fraction of successes, we can kind of see something happening. As we increase the amount of coin flips, we end up getting a little bit above 50%, we fall below 50%, we hit 50%, we go below again, we go above, and then we get closer to it. So we kind of dance around what the true probability is, and we can visualize some of this in a graph. Here we have our axes labeled with the cumulative percent of successes and the cumulative number of flips. When we flip the coin 10 times, our cumulative percent of success was only 40. Then when the coin was flipped 20 times, that jumped up to 55%. At 30 times, 46.67%, so maybe that's around here. At 40 times, we were at 50% exactly. 50 times, we fell down a little bit again to 48, maybe around there. 60 times, we were above 50% at like 53. 70, fell a little bit down closer again to 52. So what we can kind of see happening here is as you flip the coin more and more times, we're going to get closer to where this red line is for 50%. It's going to keep dancing around it until eventually everything is very, very close to 50%, and it consistently stays that way. Next thing we'll talk about is subjective probability. This is something that often comes up fairly often in real life, and this is when people assign a probability based on personal judgment, not based on experiments or other facts. So let's say you take an exam, and after the exam is done, you say that you're 70% sure you passed. How are you 70% sure you passed? In every exam you've taken in your life, have you passed them around 70% of the time? That would be experimental probability, but if you're just making this 70% up based on how you feel and not any actual facts, it would be subjective probability. We could also make the statement 100% of people that read the Bleach manga did not like the ending. If you haven't surveyed every single person that's read the Bleach manga, you can't make that assumption, even though it probably is correct, but that's just me making subjective probability again.